The easiest problem with celestial navigation is called local apparent noon. Local apparent noon, or LAN, which is commonly known, is when it travels from the horizon to your meridian, due south of you or due north of you, depending on your latitude. Now what happens there is the plane of the horizon and your great circle passing from the pole through you, through the sun, is a flat mathematical problem rather than a triangle which needs trigonometry. In this case, the sun is, let's say, due south of you on your meridian, the same longitude as you. It becomes an easy problem that you can measure with a sextant over your head to the horizon and come up with a latitude. Now how you do it is this. From over your head to your horizon is 90 degrees. So what happens is you measure the height, altitude of the sun. It gets the highest point in the sky before it starts down again. So you can take several sights, and they don't need to be really timed. All you need is a rough time so that you can go into a nautical almanac and pick out a declination to complete the problem. Now what happens is you measure from your horizon to the sun. Let's say that's 64 degrees. Now you need to find latitude. So what you do, since it's 90 degrees over your head from the horizon, is subtract that 64 from 90. Makes the problem easy. So you end up with 26 degrees. That's known as zenith distance. Zenith distance is from the sun to over your head. So now that you know the zenith distance, you can go into the nautical almanac and come out with the declination of the sun. The declination is similar to latitude. The declination of the sun, in this case, in the nautical almanac, is 16 degrees north. So by adding from over your head to the sun, then from the equator to the sun, declination, adding them together, 26 for zenith distance and 16 to the horizon, you end up with 42, and that's your latitude. So it becomes a simple problem, and it can be worked in any month, any day of the year. So let's look at it in another way. Now the easiest way to do this is to have a site form. This is a site form for local apparent noon, LAN. On it we have a DR of 4129.2 and 7117.6. So the GHA of the sun would have been pretty well the same as our longitude. But anyway, we take the site and we get 64 degrees high. We have to correct the sextant. So what we do is take a reading off the horizon to see if it's a straight line when we put the sextant on 0. If it's a straight line, we have no error. If it isn't a straight line, and we have to take and adjust the sextant to make it read a straight line, the horizon that is, we put down the difference in the reading that we had to move it to get that straight line. So in this case it was a +3 because we were minus reading. Okay, the next step then is to go into the front of the nautical almanac for what's known as the dip. We go in for dip, and this means we are looking down at the horizon, so we have to subtract whatever that angle is between the straight horizon, straight out from us, and the amount we're looking down from this height. In this case, we're 15 feet high. So we go in for dip in the nautical almanac, the word dip, and down 15 feet, and we come up with a 3.8 correction, and that's a minus. So we put that down on our sight form, and we combine these readings, add and subtract from our HS to give us what is known as the apparent altitude. Now the apparent altitude is a reading that's corrected for the sextant and height of eye, but we need to take and correct entirely for the semi-diameter under the sun, and also refraction. Refraction is where the light comes to you from the body and bends towards the perpendicular when it hits the atmosphere. In that case, the semi-diameter and refraction is 15.5. So we now apply that to the apparent altitude, and we come up to observed altitude. So this is how high the body was in our observation. Now, remember the idea of 90 degrees overhead to the horizon? We then subtract that. In this case, we get 64/19.6, which gives us a zenith distance of 2540.4. Then we go back into the nautical almanac again, into the nautical almanac for May the 3rd, and down to 1700, which is the closest time that we had to read the height of the sun. Under the sun, for 1700, we pull out a north 15, 46.6. And this is the declination of the sun that we put on the form. So by adding those together, we come up with 4126.0, and that is the latitude that we are at the present time.